Hello, and welcome back to class today. We are going to be discussing the power rule today, which is the last lesson of your checkpoint 2 assignments or tasks. And I'm going to try my best to make this one quick because I think we can get to the point pretty quickly. So what we're trying to do today is we're going to use the more efficient way to raise an exponent to a power. And remember this little catchphrase, when in doubt, stretch it out. If you cannot remember these rules, stretch things out into all of their multiplication and then see what it looks like. See if you can condense it back. All right. So here's our first example. We've got the monomial 2d squared n in parentheses, and that thing is being raised to the third power. That whole thing is being raised to the third power. So let's, first of all, okay, what does this mean? When in doubt, stretch it out. Okay, so I'm going to say that this power of 3 here means that whatever the heck this thing is, I've got 3 of them, and they're multiplying each other. All right, so I'm going to stretch it out into multiplicative form. There's 2d squared n, another 2d squared n, and a third d squared n, and it's all multiplying. Okay. And if I wanted to, I could keep stretching this stuff out too. I could keep stretching out the constants and all of these variables with their exponents into a 2 times a d times a d times an n times a 2 times a d times a d times an n times a 2 times a d times a d times an n. Those parentheses don't matter because of the associative property. But I think you kind of get the point here because of what you know from the last lessons is once you get to this point, you just multiply like you normally would. 2 times 2 times 2 is 8, okay, or 2 to the third. D or d squared times d squared times d squared. Well, how many d's do I have here when I stretch it all out? Well, that's 6 of them, and there are 3 n's. So I'm going to, at this point in time, I can use the product rule to multiply. So that is if I had a monomial and that has variables and exponents on the inside and I'm raising it to a power, you could, when in doubt, stretch it out into multiplicative form. You go, you've got 3 powers of 2, you've got 3 powers of d squared, and that ended up being d to the 6th, and you've got 3 powers of n. So my final answer was 2 to the 3rd, or 8, d to the 6th, and n to the 3rd. Now, can we find a quicker way? So let's go back to that last example and highlight. Look at what we started with. 2d squared n raised to a power of 3. And look what we ended up with. We ended up with 2 to the 3rd, d to the 6th power, and n to the 3rd power. Maybe you might be able to synthesize your rule already. Okay? And if you've got it, hold on to it, because I think what you are interpreting is the power rule. And the power rule says to raise an exponent to a power, we're going to multiply the power on the outside by every power on the inside. So what this means is this power, make sure I got the right pen here, this power of 2 in this next example, I've got this other monomial 9n squared y cubed raised to the 2nd power, gets multiplied by everyone that's on the inside. So that means 2 gets multiplied by this exponent of 3. This 2 gets multiplied by this exponent of 2. And this 2 gets multiplied onto the 9. And we have to think, what is 9's exponent? If it doesn't have an exponent there, that exponent is actually a 1. So what I'm going to end up having is 9 squared, or 81. N to the 2 times 2 is 4. And y to the 3 times 2 is 6th. Okay? And here's one of those things. If you don't believe me, if you do not trust this at all, you can, when in doubt, stretch it out. All right? So let's say you're in doubt of my trustworthiness. So you're going to say, I'm going to say that this is the monomial 9n squared y cubed, and I have 2 powers of that. And if you didn't even trust the product rule, you could actually keep on stretching out. And if you were to do it from here using the product rule, 9 times 9 is indeed 81. There are two ends here. There are two ends here multiplying each other. That's a total of 4 ends multiplying each other. And there are 3 y's here, and there are 3 y's here multiplying each other. That is a total of y to the 6th. And hopefully you trust me a little more now because we got the same exact answer. If you were to leave the 9 in exponential form as 9 squared instead of 81, that's absolutely fine. And in some cases, that'll be the better thing to do. Right? So let's try it. If we had 5 to the 3rd raised to the 6th power, 5 to the 3rd raised to the 6th power, where the power rule says I've got an exponent outside of a parentheses with exponents in it, all I'm going to do is multiply in, and that's 5 to the 3 times 6 is 18. I'd have 18 5s all multiplying each other. Or when in doubt, stretch it out. And I really don't want to stretch this one out, but you can if you do not trust me at all. That would be 5 to the 3rd 6 times. And it might become a little intuitive of why you multiply here. And the other thing that students usually say, oh, it's kind of like distribution for exponents. And that's exactly right. It is kind of like distribution for exponents. Right, so this is 5 to the 18th power, which is going to be some gargantuan number. So I'm not even going to try to multiply 5 18 times. I'm just going to leave it in exponential form. Simplified. Do as much as you can reasonably do. We're done. Right? What about this one? 16 to the negative 3rd power raised to the 12th power. Well, I'm not even going to try to figure out what 16 to the negative 3rd is and raise it to the 12th power. I'm going to use the power rule, which says exponent on the inside, exponent on the outside, they get multiplied. That's 16 to the negative 36th. And that as much as I know, that as much as I want to do, and we're done. We are going to, down the road, we are going to fix these negative exponents so they're not negative with a little trick. But for right now, this is absolutely okay. 16 to the negative 36th. Right? Try this one on your own. See if we get the same exact answer. We've got negative 3, d to the 4, g to the 5th raised to the square, raised to a 2nd power. And this is the one that is on the outside. Right? Okay, so negative 3 squared, if I think about this thing, I've got a negative inside a parenthesis, so it is indeed getting squared. Negative 3 to the 2nd power would be positive 9. Now, d to the 4th squared, 4 times 2 is d to the 8th. And g to the 5th squared, 5 times 2 is g to the 10th. And there it is. There's my new monomial answer. Or you could, when in doubt, stretch it out. So you might have crossed out this exponent and you might have gone negative 3d to the 4 times g to the 5th. And if you still didn't trust me, you might have gone like this, negative 3 d, 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 g, 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 times another one of those, negative 3 d, 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 times g, 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 g. And that's really annoying and obnoxious, right? So you get the point, though. Negative 3 times negative 3 is positive 9. How many D's did I stretch out? 1, 2, 3, 4, 5, 6, 7, 8. And I stretched out 10 G's. Let's move on. Okay. Try this one using the power rule. And you can leave any constants that you have in here, any coefficients that you have in here in exponential form if you need to. Right? So you should have gotten 4 raised to the 3rd power, or 64. X to the 2 times 3 is 6. Y to the negative 3 times positive 3 is negative 9. And we're just going to leave it like that. That is the power rule, which says the exponent on the outside gets multiplied by every exponent on the inside, including the one that the 4 has. Invisible, of course. All right, let's try this one. Now, because we are simplifying, you need to follow GEMDAS. All right, so make sure that you are paying attention to what the base is, you're paying attention to what is grouped, and you're following that that GEMDAS process. But, all right, so we've got an exponent on the outside of a group that cannot be simplified anymore. So that's the first thing that we're going to do. So I'm going to work vertically like I always do when I simplify. If you want to use the little multiplier symbol here, that's okay. And then it's going to be, well, if I were to stretch this out, I'd have 3 G's multiplying each other. And I would have 3 H's multiplying each other. And yes, that is the only thing that this exponent applies to. Exponents are all about that base, and that is it. All right, so now we have to look at what we got and see if we can simplify any further. And as it turns out, we can because, well, by the product rule, I've got h squared here times h cubed here. That is 2 powers of h times 3 powers of h. That is going to give me 5 powers of h. So that's the product rule. I'm not multiplying them that time. I'm adding them together because these are not in parentheses. This is not distributing a power from the outside of a group. When in doubt, stretch it out, and that is going to be g to the third. And there you have it. I think you have enough information to go forward with this particular lesson. You can try the rest of the examples on your notes on your own. Ask me if you have any question. See ya.